So let's start with practice worksheet 3.7. Problem number 1 is where we will start. Now there's a couple ways to graph equations, because we have to graph the equations and then find out where those two lines intersect. But there's a couple ways to graph equations. One is to use the slope-intercept form, which if we go back to dig it out of the cobwebs of our brain here, it's that y equals mx plus b, and b is the y-intercept. It's where it crosses, where the line crosses, line crosses the y-axis. And then the m is the slope. That's the rate of change. It's the rise over the run. So I'm going to use that method to graph these. It just seems to go quicker. And if we start with number 1, our y-intercept is at 2. So that means it crosses the y line right at 2. So I'll put a dot at 2. And that will be 1 point on our line. Our slope is the number on the x, which is 1, which we would write as 1 over 1, which is a rise of 1, a run of 1. So there's another point. A rise of 1, a run of 1, a rise of 1, a run of 1. And then if we connect those dots, okay, draw arrows on the end, that would be our graph of that equation. And then I'm going to do this graph of this equation also using the same method. The y-intercept, where the line crosses the y, is at 1, so that would be where one of my first dots are. And then my slope is 2 over 1, which means I'm going to rise up 2 and run 1. So I will go up 2, run 1. And there you can already see where these two lines are intersecting, right at that dot. Rise up 2, run 1. And then if I connect those dots, there's my other line. And as I said before, we could already see where the two lines intersect. So that is the solution for these two equations. And if remember, when we're drawing our ordered pairs or writing our ordered pairs, our first movements are back and forth movement, our next movements are up and down. It's opposite as of the slope, isn't it? Okay, because that's the change in y over the change in x. Here we're marking our x movement and our y movement. When we're finding our ordered pair, we start at 0, 0. Looks like we have to move over 1. So I'll put a 1 down for our x. And we have to go up 1, 2, 3. So I put a 3 down for our y. So our solution to these two lines is 1, 3. Now I can test this out real quickly to make sure I have the right point by checking it with both equations. So I can put in 1, 3 for both equations. And I'll do that right now. So the top equation, y equals x plus 2. If I put in 3 for y and 1 for x, you can see that this side, the 3 over here, does equal the other side of the equation. So yes, I know that 1, 3 is a solution for that top equation. And I can do the same thing on the bottom equation. I can put in 1 for x, and I can put in the 3 for the y, and I can see if both sides stay equal. Well, 2 times 1 is 2. 2 plus 1 is 3. So yep, both sides did equal 3. So I know that this point is truly a solution for both of those equations because I just tested it out. Okay, moving on to number 2. Y equals a negative 2x plus 2. So if we're going to graph this, we'll take a look at this top one. The y-intercept is 2, so I'm going to put a dot on 2. The slope is a negative 2, 1. So just to remind myself of that, I'm going to write down 2 to the right 1. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And then if I connect these dots, there's my line, there's the line for that equation. And now I can graph the next equation. This has the same y-intercept, so boy did that make that easy. Right there's where they're going to intersect. Still need to graph it though. My slope is 3 over 1, which means I'm going to go up 3 to the right 1. So up 3, 1, 2, 3 to the right 1. Notice I started at the y-intercept point. I could go down 3 to the left 1 also. Gives me one more point to graph. Connect those dots. Draw my arrows on the end of my line. They intersect right here. That point is, well, my first movement's back and forth. I don't have to go back or forth, so it's just 0. And I have to go up 2. So I'm going up, it's a positive 2. So my next the solution, the point where both of those, that works for both of those lines is 0, 2. Number 3. Number 3, my equation is y equals negative half x minus 1. So where it crosses the y-axis is at a negative 1 right here. My slope is a negative half. So that means I would go down 1 to the right 2. Or, you know, I could write it this way, 1 over negative 2, which means I go up 1 to the left 2. But so let's go down 1 to the right 2. Down 1 to the right 2. And like I said, I could have gone up 1 to the left 2 also. When I connect my dots, that's what that line would look like. Notice I'm drawing my lines pretty much through my graph as much as possible. That way I can definitely see where they intersect. And then for this equation, the y-intercept is at negative 4. 1, 2, 3, 4. So it's down, negative 4. And then my slope is 1. So it's a rise of 1, a run of 1, a rise of 1, a run of 1, a rise of 1, a run of 1. And then if I connect my dots for that one, draw my arrows, and there are the two equations graphed. And then the solution is where they intersect right here. And if I graph that correctly, my x is my first movement, and I have to go over 1, 2, going to the right 2, so it's a positive 2. And then I have to go down 2. Since I'm going down, I have to show that with the negative 2. So my solution is 2, negative 2. Going to number 4. Number 4, y-intercepts 3. My slope is 2. That means I'm going to rise up 2, run 1. Up 2, run 1. Now I'm going to write this with 2 negatives also, because a negative divided by negative would be a positive 2 also. So that means I could go down 2 and to the left 1. So I'm going to go from down 2 to the left 1 from that other point on the y-intercept. Now if I connect my dots, I've got my first equation graphed. And then moving on to the second equation. Now if it would help you to see it, I could just add 0 to the end of it. But it intercepts the y-axis at 0. So I'm going to put my dot there. My slope is 1 over 2, which means I rise up 1, run 2. Rise up 1, run 2. Connect my dots. Draw my arrows. It intersects right here. And this point is negative 1, 2, 3. Is that right? Negative 1, 2, 3. And then a positive 1 down. Oh, you know what? I graphed this point wrong. Sorry about that. This is supposed to be down 1 and to the right 2. It's supposed to be right there. Sorry about that. I better adjust my line slightly. Okay. Boy, that messed that up a little. Sorry. And actually, it intersects then right here. So it's my intersection would be a negative 2, negative 1. Sorry about that. That's what happens when you don't graph that carefully, huh? If I erase this just a little bit here and start that part over. So let me back up just a little bit. The blue line, it crosses here. My slope is up 1 over 2, up 1 over 2, or down 1 over 2, down 1 over 2. So as you can see, I kind of made a mess of this. Sorry about that. As you can see, the lines cross at the -2, -1. I apologize for that. Okay, moving on to number 5. Graphing the first equation, this is a +2. It crosses the y line at +2. The slope is a -3 over a +2. So it'd be down 3 to the right 2. Okay, down 3 to the right 2. So I'm going to go down 3, 1, 2, 3 to the right 2. Down 3 to the right 2. 1, 2, 3, right 2. So my line would look like this. And then for my next equation, y equals 1/2 x minus 2. I start at a -2, that's where it crosses the y-axis. My slope is 1/2, that means you go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Draw an arrow. Where the lines intersect is right here. So that point would be 2 to the right, 1 down. So the x movement's a 2, the y movement's a -1. So as you're correcting this, be giving yourself a point for the solution and giving yourself a point if you have the graph correct. Okay? Number 6. We need to graph this equation right here first. The y-intercept's a -5, which would be right here where it crosses the y. The slope is 2, so we could write it as 2 over 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Connect those dots. There's the first line. The second equation is y equals 1/4 x plus 2. It crosses the y line at that 2. There's my y equals mx plus b. There's my b where it crosses the y. My slope is 1/4. That means it's up 1 to the right 4. Up 1 to the right 4. 1, 2, 3, 4. I get it there? Okay. Up 1 to the right 4. We have to keep going with that. So it's going to cross each other right out here, right here at this point, okay? Those pink line and the blue line cross each other right there. So that point is 1, 2, 3, 4 over, and 1, 2, 3 up. So our point is 4, 3. And if you're not careful and your lines are off a little bit, you notice that you have to really watch that to make sure that you have your lines drawn carefully. That one even looks a little off when I did it, but be cautious of that. Okay, last problem, number 7. For this problem, you have to look at a few key items. One is the tomatoes for Rob's Market were 80 cents, and it does say 80 cents per pound, and that was for Rob's Market. So if we're going to write this equation, we're going to have y equals, we have to take the price and take it times the number of pounds. And it did say x is the number of pounds for that one. And then we're doing the same thing for sales, but hers were $1.20 per pound. But there's one catch to sales, and that's that coupon for $1.40 off. And it does say off. Okay, that's money you don't have to pay, so you're going to have to take that off of the price, $1.40 there. Now graphing it, you can still use that y-intercept to help you with this. This is all the number of pounds down here. And this is the price. So I'm going to label my axis so I can remember what's what. And here we have, for Rob's right here, we have 80 cents per pound. The y-intercept, you start at 0. Okay, you haven't bought any pounds. And then we're going to go up 80 cents for every pound we purchase. Right? This goes up 20 cents. I need to go up another 60 cents, so it's going to be about right there. Okay? From there, I've got, this is from here to here is 60 cents, so from here to here is 40 cents. I've got to go up another 40 cents to get to a total of 80. So I'll probably be about right here, not quite that halfway mark. So in graphing Rob's, that's about what the slope of my line looks like. Okay? And remember, each of these is per pound. Okay, now when I graph Sal's, one way I would almost recommend doing it, just to get your graph kind of started off in the right spot, is go ahead and extend this line down. I think that made that easier for me to do. And that way you can graph this y-intercept. This y-intercept is going to be about there, because it's going to be about 1.4 down, right? Dollars. So you could kind of start it there, even though you won't have negative dollars, right? But it might help you to graph it, okay? Your slope is $1.20, so we've got to go up $1.20 when we go up a pound. We're going to end up about right there. If I have to go up $1.20, well, I went up, let me think. This was $1.20. I have 20 more cents to go up, so I have to go up about $1.20 more. I'm going to go about right there, okay? I have to go up $1.20 again, so I'm up about 20 already. So if I go up the same amount plus about 20 more, right, I'm going to be about right there. $1.20 again, I'm going to be probably about right there. Okay, so you can kind of start to see where the one graph pulls away from the other, right? It's going to be about right, and this is one of that last question. Use the graph to estimate the number of pounds for which the cost is the same at either store. So if you look at about 3 pounds, right, the prices are about the same. And I'm going to write here, this is Sal's, and this was Rob's. But about 3 pounds, Sal's starts to become more expensive. And I would, so if I were going shopping and I needed under 3 pounds of tomatoes, I'd definitely go to Rob's. I'd definitely go to Sal's at first. If I knew I needed more than 3 pounds of tomatoes, it gets a lot more expensive at Sal's as you buy more pounds, doesn't it? All right, the rate is the same, but you're going to be paying more money, right, per pound if you go to Sal's. If you just need a smaller amount, I'd go to Rob's. So anyway, that's the end of this. And how I would probably, as I'm looking at this for grading it, I probably would just do and look at it and just say, well, if you got it right, give yourself a point. Okay, you did fairly well. Okay, you don't have to have everything absolutely perfect. The equations I would expect to be about right. Okay, if you have those right, give yourself just a point for number 7. Otherwise, that would just take that off. And then for up above, it was 2 points for each problem. So you can kind of figure out your total pointage depending on what problems you had to do.